Welcome to AI in 8 minutes or less, your daily AI update. Today we're diving into what I'm calling the local AI Goldilocks test. You know, it's the question everyone's asking. We hear all about these gigantic AI models running in the cloud, but what about right here on our own machines? The dream, of course, is powerful private AI without paying for a subscription. But is that dream even a reality yet? Well, to find out, we're going to go on a quest for the just right AI. So, we're going to look at an experiment that puts this whole idea to the test. And the goal's pretty simple. Find the Goldilocks of AI models. You know the story. Not too big and slow, not too small and weak, but just right. And the test machine is a really powerful piece of hardware, an NVIDIA DGX Spark, which makes this a super realistic look at what a dedicated person could get running at home. First up, we've got the absolute giant of the test, Quinn 122B. As you're about to see, this is one of the biggest models they tested, and it pushes the hardware to its absolute limit. The scale here is just staggering. We're talking 122 times billion parameters. You can kind of think of parameters as the knobs and dials an AI uses to think. And while more parameters usually means more power, it also means it needs a whole lot more muscle from the computer.
So with all that brain power, how does it handle the simplest prompt you can imagine? The researchers just fired off a basic greeting to see how long it would take to get literally any reply.
And the answer is... a while. Yeah, over a full minute for a simple 3-word response. You could go make a cup of coffee in that time. This is just a perfect example of how all that power on paper doesn't always translate to practical speed. So the bottom line is, the giant was just too slow. And that brings us to the next logical step in our little quest. What happens if we go to the complete opposite end of the spectrum? Let's bring in a much smaller, much nimbler model. And our next contender, the Sprinter, is a pretty stark contrast. I mean, we're going from Quinn's 122 billion parameters all the way down to Gemma's 8 billion. That's a massive difference. So you'd expect a pretty huge jump in performance, right? And the results were dramatic. That same "Hi, how are you" prompt took just over 5 seconds. That is more than 10 times faster. It just perfectly shows that direct trade-off between a model's size and its raw speed. Okay, so it's fast. That's a huge check in the plus column, but speed is pretty useless without some smarts to back it up. So to really test its capability, it was given a much tougher, more creative task: code a fully playable game of Space Invaders from scratch. And, well, this is where our Sprinter stumbled. Big time. While it generated the code at lightning speed, the result was, and I love this quote from the source, basically nothing. Just a single dot on a screen. The game was completely broken. So speed clearly isn't everything.
So our giant model was too slow, and our Sprinter was, well, too weak. This brings us to our third and final test. Can we find a model that gives us the best of both worlds? The smarts of a large model, but with enough speed to actually be useful?
Our final contestant is GPT-OSS. Now, at 120 billion parameters, it's nearly as large as the giant we started with. But it has a different internal architecture, and that can have a huge impact on how efficient it is. The real question is, will that difference be enough to matter? And what a difference it made! It took on the exact same Space Invaders challenge and totally knocked it out of the park. It produced really accurate code for a completely playable game. You could move the ship, you could shoot, and when you got hit, the game over screen actually worked. The whole shebang. So this model really found that sweet spot. It was powerful enough to produce high-quality, functional results, and, according to the tests, it did it at a very respectable speed, which makes it genuinely useful for real-world tasks. But we do need a little reality check here. So here's how our 3 local contenders stack up. The giant? Too slow to even get a quality score. The Sprinter was fast, but the quality was low. And our sweet spot model was fast enough and produced high-quality work. But how does this high quality compare to the absolute best AI in the entire world? And that's the crucial context. The source makes this point crystal clear. What you can run on a box in your office is still in a completely different league from the massive frontier models. These are the absolute cutting-edge systems run by the big tech companies in the cloud. They're just not playing the same game. For instance, when a frontier model like Opus 4.6, which is rumored to have trillions of parameters, was given the same Space Invaders task, it didn't just create a simple game. It created a complex, super polished version with advanced features. So the local model is what's possible on your own machine today. The frontier model shows us where we're all headed tomorrow. So what's the big takeaway from all this? The most important thing is that practical, powerful, and totally private AI on your own devices is no longer science fiction. But you have to be smart about it. It's not about finding the biggest or the fastest model. It's about finding the right model for your hardware, that perfect sweet spot. And this leaves us with a final, pretty provocative thought. We've seen what's possible right now. Today, the gap between local and these frontier models is huge, but it's shrinking. So the real question isn't if we'll get frontier-level AI in our homes, but when. If you enjoyed this, subscribe to AI in 8 minutes and never miss what matters.